So what we're going to talk about right now is inequalities. And the perspective I want you to keep in mind is that fundamentally when we talk about inequalities, it's not much different than when we talk about equalities. It's clearly not the same thing, but there's enough of the similarities that the way we think about them should coincide. So let's come up with the inequality. Let's take a look at the inequality 2x plus 3y is less than 5. And let's say we were asked to quote solve unquote or graph this inequality. You should ask yourselves, like, what does that actually mean? What does it mean for 2x plus 3y to be less than 5? And again, like I mentioned, what we want to kind of take as our inspiration is our work on equalities. So when we had equalities and linear equalities like the ones we looked at, an equation like y equals 2x plus 1, its solutions are all pairs of x and y that make the statement true. So if I say x is 1 and y is 3, that makes the statement true, right? Because if x is 1, then 2x plus 1 is in fact 3. So if I say x is negative 2 and y is negative 5, that also checks off, right? Negative 2 for x. Sorry, my mistake here. This should be minus 3, right? Minus 2 times 2 is minus 4, plus 1 is minus 3. So that checks off. So that works as well. But if I were to say 3, 5, then 2x is 6, plus 1 is 7, which is not equal to 5. So that's a no-go. That's bad, right? And so I say all that just to say the whole point is that the solution to that equality are all of the xy points that make the statement true. And for a linear equality like what we just saw, those happen to just form a line in space, right? And so let's just take a look then back at 2x plus 3y being less than 5 and just think of some things that make it true. Well, 0, 0. 0, 0 on the left hand side, we get that 0 is less than 5. So that is a true statement. So it works out perfectly, right? 1, 1. On the left hand side, we get 2 plus 3, which is 5, which is not less than 5. So that's bad. On the other hand, maybe 1, 0 would give us 2 plus 0, which is less than 5. So that's good. Negative 10, negative 20 would give us, there's no equality here, would result in negative 20 minus 60, which is negative 80, definitely less than 5, right? And so this is what it means to satisfy an inequality. It's just a pair of points that make the statement true. As you can see, there's going to be a lot of them. So if we want to see what geometrically this looks like, it maybe helps to rewrite this inequality in a way that resembles the linear equalities that we've worked with. So 2x plus 3y equal to 5 would define a line. At which line would it define? Well, we know from our initial statement that we would have that 3y is less than minus 2x plus y, and therefore y is less than minus 2/3 x plus 5/3. Now if we were to graph an XY plane and I wanted to, okay, that shouldn't be happening, but whatever. I wanted to take a look at what this equality looked like. The equality would be a downward sloping line because of the negative slope. With y-intercept 5/3. It has a negative slope of minus 2/3, and maybe we could figure out what this point of intersection would be. It would have to be 2.5. Right. And then what you're saying is, okay, that's the equality, and what I want is for my y values to be less than that. So it's everything below this, so we get this shaded region here. Another way you could see which half of this dotted line resulted in an inequality is just to take a test point and see if that satisfies it. So if I took 0, 0 here, we already saw that it did satisfy the inequality. So that checks out, right? This half should be the half. This half here should be the half that that satisfies our inequality. If on the other hand, I took a point out here and I could pick whatever I want. How about 10, 10? We would get 20 plus 30 being 50, which is not less than 5. So it's not that half. It's this half down here. And so this is the reasoning behind the inequalities and how they're graphed. If we want to see practically how we would do this, I would probably just do something like that, but then we see that we've gotten, through our reasoning, right, the same region that we would have gotten here. We have this downward sloping line as a boundary with 5/3 as our y-intercept, 2.5 as our x-intercept, and the region below this line, all these points, if I picked any one of them, I plugged them into x and y here, 2x plus 3y would in fact be less than 5, and not true for anything on the line, they would be equal to 5. Not true for anything above the line, they would be greater than 5. All right. Thank you very much. Please let me know if you have any questions. Email me, post in the discussion board, etc. Thank you very much.